Right, let's have a go at 6b then. It says find the range of values of x satisfying the inequality 5x squared plus 7x minus 6 is less than or equal to 0. So let's have a go at that then. I've written down the inequality here. It's a quadratic. So we know from a picture of it in our mind's eye that it's a U-shaped curve because the number of x squared is positive. So it's a U-shaped curve. So in essence, what we want to know is when does it lie between the two roots? So in your mind's eye, you'll see something that looks like that. If it has two roots, then that's when it will go below the x-axis. Now you'll notice that it's less than or equal to, so we're interested in this range here when it lies below the axis because this value has to be negative, but it can touch this value here. So we want to find these two values of the roots, don't we? Now we can use a formula to solve this quadratic equal to naught, or we could try, and that's what we're going to do here, is just factorize it. So 5x, well there's not a lot of choice with 5x, so we can just write 5x and x. Now how are we going to get 6? 6 and 1 or 3 and 2? 3 and 2, see it? 2 5s are 10, 3 1s are 3, and the difference between 10 and 3 is 7. So it looks like it would be 2 there and 3 there, right? Now I need a plus and a minus, but because that's plus 7, that would need to be plus, wouldn't it? Because you get plus 10, minus 3 is the plus 7. So let's double check it now. 5x squared is the first term. Then we've got 10x, take 3x is the middle terms. 10x take 3x is 7x. And then minus times plus is a minus, 3 2s is 6, so that's fine. Everything's good there. So now we have got our quadratic here, which looks like this on the axes. When does this equal naught? Well, that equals naught. So here, x plus 2 equals naught implies, if that were equal to naught, then x would equal minus 2. And 5x minus 3 is the next one. When does that equal naught? Well, that equals naught when 5x equals 3. And then divide by 5, or move the 5 from times to divide. X equals 3 fifths. So there's our two roots then. One happens at, minus 2, which is that one. And the other one happens at 3 fifths. So the values of the x that we can take must lie between these two values because of the shape of the curve of the quadratic. So we can now say that x must be less than or equal to 3 fifths because it can equal 0 because of this less than or equal to, and it can be greater than or equal to minus 2. There we are. That's it. Good, that's 6p done. Great.